All right, so give me a moment because Arina got kicked out from the call. So it really was somebody. Okay, so yeah, last week we discussed about Newton's method, where we can find the roots between in the given interval for a continuous function. Okay, so that is one of the numerical methods to determine. Okay, first we learn about the algebraic approach and the graphical approach, and then we learn about Newton-Raphson method, where we find the value of the root lah. So let me okay, I think she's in, right? Sorry. Okay. So wait. Okay. Si Aisyah kata okay. Okay, no problem. So okay, so this week today we will be learning about integration. Did I spell it correctly? Hold on, let me check. Sorry guys. Abdullah, integration. Okay, so basically I would like to talk about integration. So previously, back in the day, they don't have any methods to find the area for a curve under a curve. So they have this method which is called Riemann sum. Riemann sum is where they find the areas for infinitely many rectangles under the curve, and then the more rectangles it is, the more closer it becomes to an actual value for the area under the curve. So that's a bit history lah. But then, okay, enough of the boring topic, just the history of integration. Now let's go into our main agenda. So, we see the relation between integration and differentiation, where if you learn about calculus, you will be introduced to the fundamental theorems of calculus, where you see the relationship between the integration and differentiation. But in a nutshell, basically, you have this. So when you integrate a function of f of x dx is equal to fx. This is the antiderivative. Here is your integrand. Here is your integral, your notation for integral. And then here's your lower limit, here's your upper limit, okay? So those are the simple things that you need to know. And then based on the fundamental theorems of calculus, which I learned, but you guys have to learn. But anyway, basically, when you differentiate this, d dx, yes, like this. As far as I know, you will get this. And at the end, you will get this lah. F of x. You will get f of x lah. Right? But when you integrate, and sorry, I forgot to put at C, because when you integrate an indefinite integral, then you have constant, because any kind of function, when we integrate it, there exists a constant, different constants. It depends on the upper and lower limit in a way, okay? Where we determine the value of C. But for now, for indefinite integrals, any function where we integrate, there will always be this constant, okay? Right? But if you want to know more, you could check out mean value theorem, the corollary about mean value theorem about this particular thing, where when you differentiate two functions, you will get when you differentiate both functions, both equal functions, let's say that. I don't want to show you. It's okay. I'm not going to show you that much, but anyway, I don't want to go into it that much since you guys only learn on the surface. So I'll be introduced you guys to the basic rules of integration. As you all know, okay, let's say k is a constant. Okay, k is a real number. So when you integrate k in respect of x, okay, like integrate k in respect of x, meaning that okay, this is a variable. So when you integrate the constant, you will get k of x plus c. If you integrate, let's say your variable here will be dy, so it will be ky plus c. What happens if we have to deal with d pi? Then you will get k pi lah, k pi plus c, and so on and so forth. Okay, so those are the things that you have to know. Okay, you have to be careful lah. If your lecturer decides to put a different variable, then you have to follow it. Okay. Okay. It's okay. I'm recording. All right. So any questions for our first rule? If not, then we can carry on. Okay. Yeah. All right. So for our next rule, we we are introduced with the power rule in a way where for integrate of x to the power of n dx, the power will add 1, and then and then it will divide by n plus 1 plus c. Okay, as long as n can be any number. Okay, wait, for now we only discuss about rational numbers lah. Yeah, rational numbers, but then n cannot be -1. Okay, later on you will see why. There will be another section you will learn. All right, and then you have, okay, what happens if you have a function that has a multiple which is a constant now? For example, integrate k f of x dx. Okay, then based on this, right, any constant you have, you could bring out from the integrand. Basically, you have k, the integrate for f of x dx. Then you could solve from there, right? And then another cool rule. I don't know whether I should call it a rule or a base or a property. Wait, let me. Honestly, I am really careful on using terms. Yeah. Mm, integral. Oh, linear. Funny. Integral of f. Integral of x. Integrate x. Okay. Okay. All right. So the next one is another rule, which is we integrate f of x plus minus g of x, as long as both of these functions are integrable. In other words, they can be integrated lah. Because one of the like criteria for them to be integrable is that both of them have to be continuous. But then that is I'm very sorry when I explain this, because I love to mention small things about it. If you're wondering, all right. So and then there's the this rule states that you could do it like this. It's like expanding the integral. All right. And then another one is for, it's not yeah, it's a binomial. It's a binomial in a way. Yeah, it's a binomial. So when you integrate a binomial with a power of n, where n cannot be -1, then we will get here. Sorry, yeah. Ax plus b to the power of n plus 1 divided by n plus 1 times a. You will see later on, we will be using use substitution. Like, you don't need to memorize this fifth rule. You only need use substitution to find the when you want to integrate. Okay. Okay, any questions so far from both of you? I think Arjuna has problems with her Wi-Fi, which is understandable, no problem. Not the prof. Thank you. Thank you for reminding us. Okay, no questions then? All right then. So let's go through the questions. No, honestly, don't call me Sid. I rather you call me Arif lah, because I like that name. It means that it has a good meaning to it. Okay, but if you want to call me Sid, then go ahead lah. I don't want to force you to call me anything. As long as it is appropriate. Okay. So now find the following integrals. So all these are elementary in a way. You just follow the rules of integration, which you are given, which where integrate t, 3 dx, you will get 3 of x, 3x, 3x plus c. Remember, for indefinite integrals, you have to add a constant, okay? But if you want to know more, I think in a nutshell, basically, if you have two identical functions but with different constants, in a way like, let's say, 3x plus 5, and then we have 3x plus 4, when you differentiate both of these in respect of x, you will get the same value, which is 3 and 3. So in other words, when you integrate 3, your idea could get a constant of 5, a constant of 4. It depends on your limits, your lower upper limit, if you want to find your c. Okay, so that is one of the things that why we have to add a constant to our indefinite integral. Okay, so that is nothing much to worry about. Okay, and then we have how exponents. We have another one, which is integrate x to the power 6 dx, where we apply the fourth rule, which is x to the power 7 over 7 plus c. Okay. And then how about this other one, which is integrate 1 over square root of x dx. You should get, okay, first you change by using one of the laws for exponents. I don't remember the name, but you make the power to a negative power lah. So integrate from x to the power of negative 1 over 2 dx. And then apply the fourth rule, and then you'll get x to the power negative 1 over 2 plus 1 over negative 1 over 2 plus 1 plus c. And then you should get 2, I think it's 2, yeah, 2 over, no, it's not 2 over, it's 2 square root of x plus c. Okay, so that is really straightforward questions. All right, so hopefully you guys have no problem, but if you do, feel free to ask lah. Okay, feel free to ask. I am open to any questions to make sure you guys understand. Right? Okay, so let's move on. Okay, it's not a tougher question. It's just basically you just follow the rules. Okay. So now square root of negative 2 squared, sorry, not squared. We integrate negative 2 times square root of x dx. The first, if you want to bring out your constant outside of this integral, then no problem, you can do that. But if you want to stay it inside your integral, then also no problem. But since we are applying the rules of integration, then we should follow by using, I think, the fourth rule, if I'm not mistaken. No, first rule. Sorry, the first rule states that, the first is about constant. The third rule states that if a function is multiplied by a constant, then you could bring out the constant outside the integral. So from here, you could do this. Then, as usual, negative 2, integrate x to the power of 1 over 2 dx. Negative 2. X to the power of 1 over 2 plus 1 divided by 1 over 2, 1 over 2 plus 1 plus c. And then from here, just solve this, and you should get in this form. And then simplify this expression, you will get 4x, sorry, it's not negative, negative 4x to the power of 3 over 2 over 3. Okay. So that's about it. And then, there is a lot of questions. And then we have, for a binomial. Okay, let me give you an example for a binomial. Let's say you have, you integrate x squared plus y to the power 2. If you want to apply the binomial theorem, you can, no problem. Because we can't apply the fifth rule for integration, because as you can see, this is not a linear expression. This is a quadratic or polynomial degree of 2. Okay, sorry. Okay, here is a polynomial with degree of 2, so you can't just apply the fifth rule of integration. But here we see we can expand. Okay, we can expand, no problem. And then from there, solve as usual based on the rules that you are given. Okay, simple as that. Okay, so um, okay, so any questions so far? So far now, any questions? All right, nice. So, if there's no questions, let's move on to the next section where we will be finding integral of e exponent bx plus c, and then we have, wow, a rational function, a rational term, a rational function, a rational expression. Then we have a to the power of bx plus c. Okay, so wow, all right. Okay, so all right, a proof. You want a proof? I mean, we don't need proofs because as for now, if you want proofs, then you can find yourself lah. But as for now, we just apply the form that's been given. From here, they're given e to the power bx plus c. So e to the power bx plus c dx is equal to e to the power bx plus c over b plus c. Okay. I mean, generally speaking, I mean, if you want to memorize this, no problem, because we have a similar formula, which is um, a to the power of bx plus c d of x. Sorry, dx. Sorry, a to the power of bx plus c dx is equal to a to the power of bx plus c over ln a times with b. Okay, ln a times with b. So, yeah, that's about it. Nothing much to see here. I mean, these are equivalent in a way where if you apply the same thing, right? Ln e is equal to 1. That's why there is no ln e lah, because it's equal to 1. So that's about it. Nothing much. And then you have this integral where integrate 1 over bx plus c dx. You will obtain 1 over b ln bx plus c plus c. Okay, then that's about it. Okay, this tree, as long as you know what you're doing, right? Because later on, you can apply use substitution if you don't want to memorize this formulas. Later, I'll show you lah. But okay, simple thing. So let's say, and okay, I think you guys have, yeah, I'll not introduce it. I'll introduce use substitution later. Okay, so yeah, nothing much. Okay, let's say we integrate for e to the power of 2x minus 2 dx. Then when you integrate this, you will get for e to the power of 2x minus 2 over ln e. Then we have 2. And then simplify this, you will get 2 to the e to the power of 2x minus 2 plus c. Okay, don't forget your constants. Okay. So that's basically it. That is basically it. And then another one for ln. Okay, let's say we integrate 2 over x dx. We bring up 2 up front. We'll get integrate 1 over x dx. And you will get 2 ln x plus c. Right? And it's just basically you are applying the formulas lah. You are just applying the rules for integration, and then the formulas been given. Just apply it. But if you really want to get, like I said, if you want to get into integration, then you have to start with fundamental theorem of calculus lah. They will show you. They will not give you the formulas straight away. They will give you the proof of how they derive the formulas as it is. Then you apply the formulas. Okay. All right. Okay. So it seems that I am done. Well, kind of. Yeah, I'm kind of done. Then let me show you one more. For we integrate, let's say 2 to the power 7x minus 1 dx. Then just apply the formula that you've been given. You will get 2 to the power 7x minus 1 over ln 2 times 7 plus c. And you simplify this, you will get 2 to the power of 7x minus 1 divided by 7 ln 2 plus c. Simple as that. Nothing much to be worried about. Okay. Okay. So they actually gave me a tutorial question, which is going to be very useful. Oh, he did. Oh, yeah, he did before. Wait. Sorry. I recall that he gave me one file. Here you go. All right, so let us answer a few tutorial questions. But before we go into it, do you guys have any questions before we start the tutorial? By the way, Shafia, if you have questions from your own tutorial as well, feel free to send it in the group for me to answer it straight away, all right? And by the way, Shafia, is Arina with you? Because she hasn't joined the meet here. So is she with you? Is it? Or she's not? Yeah. Okay. Dia update GBB. Oh, I see. Okay, that's okay. Saya record so she can refer to back. Okay. So, okay, I'll be referring to KML tutorial if you don't mind, Huzaifa. Huzaifa, sorry. I need to, oh yeah, Huzaifa, do that. Okay, so let's try. Wow. Verify f of x is the antiderivative of f of x. Okay, 7. Okay, all right. Okay, verify that f of x is the antiderivative of f of x. Okay, all right. So since we are dealing antiderivatives, it should be like this lah. So integrate f of x dx is equal to f of x. This big F here represents the antiderivative. So the first question asked is, given the antiderivative, honestly, right, they should put plus c because we are dealing with, indefinite integrals. But some reason they didn't put plus c. But anyway, okay, we have to verify for f of x. So let's apply the rules of integration. So we integrate 4x dx. You obtain 4x 1 plus 1 over 1 plus 1 plus c. Then we can from here simplify, no biggie, you will get 2x power 2 plus c. Then that is the antiderivative for this indefinite integral. Right? So yeah, that's really nice. Oh, I haven't taught integrate by substitution, is it? Okay. But then your question, right, 1B, well, for me, right, we have to use the substitution method, but we haven't got into it yet. But, wow, okay. That's okay, no problem. All right, I'm going to go through the second question. Okay, the second question, 2A, they give us an integral, which is 4 times the square root of 2 minus 5x dx. Now, if you see it's square, right, change it to a power. So convert it to a power. So you get 4 times 2 minus 5x to the power of 1 over 2 dx. Since 4 is a constant, right, we refer back to our third rule, which is the constant times the function. You will factor it out. Not factor it out. I mean, bring out from the integral. So you get 4 integrate 2 minus 5x to the power of 1 over 2 dx. If I here apply the fifth rule, since we are dealing a binomial and it's the power of 1, x here, so we will get 2 minus 5x to the power of 1 over 2 plus 1 divided by 1 over 2 plus 1 times negative 5. Okay, and then plus c. All right, so you try to simplify this, you will obtain 4 times with 2 minus 5x to the power of 3 over 2 divided by, and 3 over 2, negative 15 over 2. Okay, when a constant multiplied by constant, you will get a constant at the end. And then when you simplify this expression, you should get negative 8. Yeah. 2 minus 5x to the power of 3 over 2 divided by 15. Okay, that should be your answer. Okay, by applying the rules of integration that you've been given, all right? So yeah, I think my one's correct lah. So extra questions. Yeah, but can say what negative 8. Oh, sorry. Plus C, I forgot. Negative 8. All right. It seems correct. Okay. I will check. Okay. So, okay, let us try another question. Question B, where we are given an integral, which is square root of x plus with 2 over cube root of x plus 2 dx. Okay, first things first, you make sure your terms are power of 1 over 2, power 1 over 3, etc. because you want to apply the basic rules. Okay, so let's try from here. X to the power of 1 over 2 plus 2 over x to the power of 1 over 3 plus 2 dx. Then from here, first, if you want, I can change this to a negative power. So you will get integrate x to the power of 1 over 2 plus 2x negative 1 over 3 to the power of negative 1 over 3 plus 2 dx. Integrate, then I think you should get x to the power of 1 over 2 plus 1 over 1 over 2 plus 1 plus 2 x negative 1 over 3 plus 1 over negative 1 over 3 plus 1 plus 2x plus c. And then try to simplify this expression, this equation, that you will get 2x to the power of 3 over 2 over 3. And then this one, you should get plus 3. No, yeah. 2x to the power of 2 over 3 over 2 plus 2x plus c. And then if I am not mistaken, from here you could simplify this. You should get 2x to the power of 3 over 2 over 3 plus 3 x to the power of 2 over 3 plus 2x plus c. All right, you should get that one. Okay. If you want to recheck it, you could like differentiate in respect of x, and you should get the final answer. No, you should get the previous function, right? So, any questions so far? Hopefully, you guys understood what I wrote down. But if you do have questions, please do ask so that I could like make sure like you guys get it. All right. Nice. Okay. Right, nice. Thank you. Okay, so let's go through to another form of question. AJ. Okay. All right, so let's go through to another form, which is question 3. Okay, we are given question A, which is we integrate e to the power of 4x plus 1 dx. Okay, we integrate it by using the formula that we have been given. Okay, so you will get e to the power 4x plus 1 divided by ln e 4 plus c, and then you will get e to the power 4x plus 1 over 4 plus c. Ta-da! Okay, how about another one? Mm, I'll go for C lah. Question C, they give us a base 3. Okay, 3 to the power of 1 minus x dx. Now, as usual, 3 to the power of 1 minus x over ln 3 minus 1 plus c, and then you obviously simplify this. Minus 3 to the power of 1 minus x over ln 3. Let's see. Okay, straightforward as usual. Nothing much to worry about. Okay, and then, all right, let's try. Okay, let's try this one. So if you have this kind of question, right, say integrate e to the power of x plus e to the power of negative 2x, the times with e to the power of 2x. I think it's a typo lah. Yeah, a few questions in your tutorial have a few typos here and there because sometimes you forgot to write the dx. So it's okay. That happens. Okay, so now if you have this kind of question, in my opinion, just expand it as usual. Don't think about too much. Just expand it. You should get we integrate e to the power of 3x plus 1 dx. And then just apply the rules of integration and then the formulas that you already read before. You will get e to the power 3x over 3 plus x plus c. Okay? Don't forget about c as usual. Okay, and then the final question which I want to pick is question 4. Sorry. This one is 4, okay, not D. This one is 4. The next question I want to pick is 5C. Now 5C here is we integrate 3 over 1 minus 2x dx. And then as you may know, we apply the rules, the formulas. For this one, it's the third rule where it's a constant times a function. So we obtain 3, we integrate 1 over 1 minus 2x dx. To integrate this, you should get negative, 3 negative 1 over 2 ln 1 minus 2x. Okay, let's see. Then minus 3 over 2 ln 1 minus 2x. Let's see. If you guys have a hard time to remember, I suggest you guys use the substitution method. Okay, I'm going to show you. Even though I haven't got into it, but I'm going to show you. So we know, generally speaking, let's say we integrate 1 over x in dx, we will get 1, ln modulus of x plus c. This is true lah. But how do we obtain if we have this question, which is 3 over 1 minus 2x dx? Now, one of the ways is we apply the u substitution. So we let u is equal to 1 minus 2x. We differentiate it. Okay, this is how we apply the u substitution method. Negative 2 dx. Then you get negative 1 over 2 du times negative 1 over 2 du equal to dx. And then we know 3 is a constant, and it's multiplied by a function here. So when you apply the third rule of integration, you should get 3, 1 over 1 minus 2x dx. Now just substitute here, you get 3, 1 over u. Okay, this dot indicates multiplication, okay? So negative 1 over 2 du. Then try to simplify this. Okay, you know this is constant, right? So bring out from this integral, you get negative 3 over 2 Integrate 1 over u du. And you see here, there's a bit similarity between both of them. This one, okay, both of them are similar lah, basically. So just follow lah. So you get negative 3 over 2 ln u plus c. But then we know u is 1 minus 2x. So just resubstitute back ln 1 minus 2x plus c. Okay, we got the same answer. But to me, this is a much more better lah. In a way, it's far better in my opinion. When you don't need to memorize the formula, just as long as you know that simple integral, you could apply it to anywhere and by using the use substitution method, right? So that's one of the methods that we will be we will look into it for today, but who knows, maybe we'll have the time. Okay. So far, any questions from both of you, Huzaifa and Shafia? Any questions so far? Faham, eh? Yeah, naman. Tago. But if you have any questions, just ask me in the chat box. Yes, Huzaifa, never. Okay, guys. Okay, hopefully Shafia faham, ataupun if Shafia tak faham, you may ask, no problem. I could explain it again if you want to. Fine. All right, nice. Okay, so now let's go to integration of trigonometric functions. Now, use substitute on the use substitution method. Dalam tahu ni pula. Trigonometric functions. Korang tak belajar use substitution method mana? Techniques of integration. Okay, jumpa. Okay, sorry. Okay. Yeah, so basically, one of the techniques of integration is by using use substitution. Because there's a lot of methods. We have trig substitution, use substitution, integrate by part. There's a lot of methods to solve, but no worries. Okay. All right, so let's continue on to our next subtopic, which is integration of trigonometric functions. All right. Now, this really you have to memorize. But yes, you could also use the trig substitution method. Use substitution method. You could apply that, no problem. So let me create a page. Okay. So a few of the integral of trigonometric functions here we have for the first one, integrate sine x dx is equal to negative cosine x plus c. But if you have a coefficient in front of the x, okay, let's say sine ax dx, you will obtain negative cosine of ax over a plus c. Okay. But another one, which is cosine, so let's say we integrate cosine of x dx, you will obtain sine of x plus c. If you have a coefficient in front of x, then you will obtain similar to our initial formula. Cosine of ax, sine ax over a plus c. Okay. But then if you don't want to remember, you could always just use substitution method lah. But as long as you know this and this one, if you remember both of them, then there should be no problem when you apply the use substitution method later on. Then another one, which I forgot, is second square. Second square of x, you will obtain tangent of x. Let's see. Or even you could do here. Second, if you have a coefficient in front of x, you should obtain tangent ax over a. Let's see. Okay. Okay. So tangent. I mean, we have they showed you on why it is what it is by using one of the fundamental theorems of calculus here they showed. But as for now, as long as you know this simple, or this is the the foundation for this topic, and if you remember this, there should not be no problem. But here they use the antiderivative to prove this to show that why it creates this kind of integration. Sorry, integral. Integration is a process. Integration. Okay. So let's apply. I think someone joined, or she left. Okay. Okay, let us apply to a few examples. So let's say we integrate sine 4x dx. And yep, we integrate and we will obtain negative cosine of 4x over 4 plus c. And then if I use the substitution method, okay, so this is another method to the first one. So let's say yes, this the similar one here. Okay, let u is equal to 4x. We differentiate it, creates 4 dx. Then we have here 1 over 4 du is equal to dx. Then this implies sine u times with 1 over 4 du. And then remember, constant times the function, you could bring out from this integral, you should get 1 over 4 sine u du. Then you should get negative 1 over 4 cosine u plus c. And you know that u is equal to 4x, so you will obtain negative 1 over 4 cosine 4x plus c. Okay. Right. So let's try. I think the rest is the same. Yeah, the rest is the same. Okay, let's say we have another one. Another example, and then we'll move on to the tutorial questions. Oh yeah, I forgot to mention about the trigonometry identities. Yeah, I forgot. Yeah, the trig identities. Don't forget about that. Okay, it's very essential for your current topic. Okay, so are you can explain why we choose 4x as u? Oh, okay. Why do we choose? In my opinion, we have this method called trial and error because as we learn higher levels, right, there are more complicated equations which I already showed you before. So you have to try and error. Okay, but here it's really straightforward because this is the only one where when you differentiate it, it's equivalent to dx here, dx. So our main goal is to find a term which is similar in our integral when we use the use substitution, like this one. This is similar to this, so we could substitute it. That's what we call the substitute method. You see, there's a similar between those two, and we could substitute in terms of u, and then from here, we just applied the original formula lah. Okay, the ones where I highlighted before. Okay, okay, and then but here, right, that is the only option you have lah. If you want to use substitution, that's basically the only option you have. Okay, but unless if you are dealing with other functions, so let's say, right, um, you integrate, let's say, x squared plus 2x times with 2x plus 2 dx. How do you integrate this? You could integrate it by expanding it, but you could also use substitution. What? Let u is equal to x squared plus 2x. Differentiate in respect of x, you will get du is equal to 2x plus 2 dx. And as you can see here, this is similar to this. So you could substitute. Okay. And then you should get u du. Then you integrate by using the basic rules, the rules of integration, u to the power of 1 plus 1 divided by 1 plus 1. And you get the integral for u. And then you resubstitute the value of u into your final answer. Right? Okay, hopefully that clears up about why I choose for x. But yeah, that's the only option I have. I substitute for x. There's nothing else that I have to reconsider. But like, here I have another one. Okay, let's say you have two. Let's say you integrate, you have 2x times sine, and you have x squared. How do you solve this? How do you solve it? None other than you have to use substitution. So you let u is equal to x squared, and then you differentiate in respect of x, you get du 2 x dx. And when you rearrange these terms, when you rearrange them, okay, you have to rearrange the sine of x squared times with 2x dx. You rearrange it, and as you can see, both of them are similar. You could substitute. You will get integrate sine of u times with du. No, sorry, not times, just basically du at the end, du. And then you will get negative cosine of u plus c, and then you get negative cos x squared plus c. Okay, like that. I can't substitute 2x. If I choose 2x as to be my substitution, when I differentiate, I got 2. Where do I put my 2? Because, okay, let's say let u is equal to x. Yeah, 2x. And then you differentiate in respect of x, you get 2 times dx. And then you are left with your integral x sine square du. Now, this doesn't solve the problem yet. So that is why the most appropriate substitution is x squared. So in a sense, basically in a nutshell, is try and error. You have to try and error with every substitution you make. It is a tedious process, but the more you do tutorials, right, the more you expose yourself to questions for integration, the more you will be familiar with this substitution. Okay, that's my tips on how to apply that method. But honestly, right, that's another subtopic. I don't know why I'm explaining in detail about how we apply this method, but yeah, it's fine. Okay. So any questions so far? But if you do, feel free to ask. I will try to answer as far. Okay, good to know. Shafia, how about you? Okay. All right. All right. Okay. Nice. So, um, hmm, what else? Okay. Sorry. It's okay. It's okay. No worries, Shafia. I understood KMK has a it's really difficult to have online classes because the line is very slow. All right, I understand your situation, no problem. Okay, so find the following integrals. Okay, I think that should be enough. Yeah, I think we can like yeah. Let's stop from until here lah. We stop here. So we already covered about the basic rules of integration, and then we already covered a few formulas for exponents for ln or other in other terms logarithms. Then we already covered a bit about trigonometric functions. So I'm thinking of mm, this weekend. I'm not sure. I'll let you know by tomorrow whether I want to do our second class because there's a lot of things that we have to cover for integration, and I will let you know by tomorrow whether we want to do on Sunday or something else. But this is our part one. Okay, basically this is part one. But I'm sorry if I got into the substitution method very early because I see it as a very useful tool. Because you don't have to memorize all the formulas. You just have to memorize the fundamentals of it, and then just apply the use substitution and method, and you're good to go, right?
So, itulah mungkin video yang saya rakam minggu lepas mungkin tak sebegitu baik lah in a way. Alright, aku Huzaifah baru masuk. Okay. Alright, so hopefully saya dah kembali sihat insyaAllah untuk teruskan. Okay, so let's have a look. Sorry. Hello everyone. Today we'll be continuing on for I think yeah about the trait identities. Okay, and then I think you are familiar lah. So I think we already touched upon second square, cosine, I think tangent. Okay, all right. So let's continue. Let us continue for double angle formulas. Okay, on which this is very fundamental lah. Okay, oh no, sorry, this is very elementary in a way where we could derive the double angle formulas into their respective, no, not formulas, identities. Okay. So let's say, for example, sine 2x. Now we okay, as you recall, sine 2x is equivalent to 2 sine of x cosine of x. Okay. Then another identity is cosine 2x. In cosine 2x, we could like write it in the form of cosine square minus sine square x, and then we have 2 cosine square x minus 1, and then we have the last one, which is minus 2 sine square x. Okay, the reason why we can derive in these three kind of forms because we are referring back to this identity, which is sine square of x plus cosine square x is equal to 1. So we refer this formula and you express it either sine square x or cosine square x. Then you could just substitute into this lah. Then either you will get the first one or the second one, okay? And then yeah, you could derive the formula in expressing sine square, for example, right? For this one, you could write it as sine square of x is equal to 1 minus cosine of 2x over 2. Okay, by using basic algebra lah. Okay, you just have to apply the algebra, I think rules of algebra, not mistaken, laws, whatever. And then you express it whether you want to express it in sine square x or cosine square x. Okay, either way, it depends on the integral that you are dealing with. Okay, let us go for the first example. We integrate sine square x dx, and we know that there isn't a rule, okay, or a method to integrate a trick with the power of 2. All right, so what you can do is you can derive this expression to another form, which is equivalent. Okay, so wait, Saya lupa lah tengok. Okay, screen saya okay. Alright, so we could derive span square x. Like I showed you here, you could change it to 1 minus cosine 2x over 2 dx. Okay, and then you could apply lah. Alright, so you could, firstly, you could like separate the fraction to make it two terms like this. And then you could like integrate one by one, no problem. But if you are a pro, you can integrate it directly lah, without doing this step. Okay, without showing this step. But unless you want, but to be careful, I suggest you guys do this lah. Okay, so cosine of 2x over 2 dx. Then just integrate it as usual, x over 2, and then minus sine 2x over 4 plus c. Okay, so that is good, okay, if you know. So any questions with us, or can we move on? Okay, if there's no questions, then I'll move on to the second question. Yeah. Mm. Wow, all right, nice. Okay, so the second question we have here is, it wants us to integrate to cosine square x dx. Okay, now if you recall, let us recall to this formula here, this one and this one. Okay, so let us write down first, and then we derive the formula based on our integral here. So cosine 2x is equal to 2 cosine square x minus 1. And then you can, well, if you want to, you could express it, you can express cosine square x. But for me, when I see this integral, I see it as 2 cosine square of x. So all I have to do is just add 1 both sides to this identity, and we should get cosine of 2x plus 1. And then from here, we can substitute it into the integral. Thus, we could integrate properly lah. Okay, so plus 1 dx. From here, you should get sine 2x over 2 plus x plus c. Okay, don't forget about the c, because this is the indefinite integral lah. Like well, since if we differentiate this, right, we will, of course, we will obtain the original integrand. We call this as integrand. But remember, the constant will always be 0 like, when we differentiate in respect of x. So there could be any possible constants out there which will give us the same integrand. So that's why we put the c lah, to indicate, oh, c can be any number. Okay. All right. So that is good so far. I have another one before we move on to the compound angle formula. Okay, so let's go through one last time, which is they give us the integral of 3 sine of square x over 2 dx. Okay, so now you might be puzzled lah, because all of a sudden we have to deal with a fraction, which is x over 2. But no worries, let us see a pattern. Okay, so let us bring out the formula, the identity, which is cosine of 2x, which is equivalent to 1 minus 2 sine square of x. So as you can see here, this is 2x double angular, and this is x. So what happens if we derive a cosine of x? Then our expected output would be 1 minus 2 sine of square x over 2. Okay, then this applies to everything. If you have cosine for x, you will get 1 minus 2 sine square 2x, and so on, right? So you can now express sine square of x over 2. So you will get sine square x over 2 is equal to 1 minus cosine of x over 2. So now you could see here, this is similar. So all you have to do is just substitute into the integral here. 3 times with 1 minus cosine of x over 2 dx. Let's solve as usual. You should get 3x over 2 minus 3 sine of x over 2 plus c. Okay, so that is your integral for 3 sine square x over 2. Okay, but yeah, that's about it. So any questions before I move on? For yeah, okay. Any questions? Okay, if there is no questions, then I'll be moving on for compound angles. Okay. All right. So let us go through integration of trigonometric functions involving compound angles. Now, we know that we could derive our double angles based on this identity formula, which is sine A plus minus B. Okay. So generally, we've learned for sine, cosine, and tangent, they are compound angles. So let's go through one by one. Oh, in your notes here, it doesn't specify about tangent. So yeah. So I think for now, you only have to know about these two compound angles, which is sine A plus minus B. So what is the expected output for A plus minus B, right? So we should get sine A times cosine B plus minus sine B cosine of A. Okay, so this part is easy because the signs here are similar. If it's A plus B, then we will get sine A cosine B plus cosine A plus sine B. Sorry, cosine A sine B. But how about for cosine? The compound angle for cosine. Now, it's just basically the opposite. Like if it's plus, then it will be minus. If it's minus, then it will be plus. Okay. So cosine of A plus B, you should get cosine of A times cosine of B minus plus sine A sine B. Okay. So these two are important when you want to integrate. So let us go through one question only, because nothing much here. All you have to do is just refer to the formula. Now, let us integrate. Let's say, sorry, let's say we have sine of x cosine of 2x plus cosine x sine 2x. All right. Now, obviously, if we refer to the formula, you could recognize which compound angle you'll be using, and it's sine A. Okay, if you see sine equals sine 2x, sine x equals sine x sine 2x, it's very similar to our compound angle here. So just refer to it and then apply it to the compound angle here. So you get x plus 2x dx. Then just simplify this, you will get 3x dx. And then just integrate it. You should get cosine of 3x over 3 plus c. That is your final answer. Right? Okay, so let us move on. Okay, so if there is no questions, right, I'll be moving on. So let's move on to techniques of integration. Now, this is very important because you will be dealing with much more complicated integrals where you have to use this techniques, substitution method, and then IBP for short, which is integration by parts. And then you have to integrate a rational function. Sorry. All right then. So basically, for integration by use substitution, generally speaking, we would refer to this. We integrate a function inside of another function. Basically, it is using chain ruler in a way. The x and the fu. Sorry. You, oof, this is dusty. Okay, so equals to integrate f of u du. All right. Okay, now let's see in a few examples. All right. So, by using substitution method, find. Okay, let's go through the first question. So they gave us an integral 3 times 2x plus 1 to the power of 2 over 3 dx. Now, you might be thinking, we could use the rules of integration, right, previously. But as a student, right, we have a lot of things to memorize, especially for science, for higher students, I think. You have to memorize your biology terms and so on. So let's not try to burden ourselves with more things to memorize. But they use methods, which is one of which are using substitution method. Okay, but how do we do that? Well, first you have to identify lah, uh, which one is suitable. So from here you could see. Oh, by the way, there is no easy method for substitution method. It's a try and error method. But the more you do questions which relates to this particular method, the more you are familiar with on how to execute this kind of questions. So for me, when I see here, what happens if I substitute this particular, I think it's an expression. Okay, so let u is equal to 3, sorry, 2x plus 1. Now we differentiate in respect of x, we will get du is equal to 2 dx. Now we are treating this here as like a variable. I'm not saying it's a variable. I'm just saying we treat it as a variable for this method lah. Okay, so you have to find the similarities from in our integral with this. Then you can proceed with the use substitution method. Okay, but here we don't have the value of 2, right? We only have the value of 3, so we can't just directly substitute it. We have to express the x in du, terms of du lah. Okay, so simply we would solve it like this, and then as you can see, dx, right? Then we could solve it from there lah. Right? We will get oops, sorry, 3 times u to the power of 2 over 3 du over 2. All right, this here dot it presents a multiplication, okay? But ask your madam or sir to confirm whether you could use this notation for multiplication. Okay, because I'm used to it and it's simpler lah to use. Okay, so from here just apply the basic rules of integration, which is the one I think the first rule, isn't it? Is the power rule. All right, so it will be 3 over 2 u 3 to the power of 3 over 2 plus 1 over 3 over 2 plus 1 plus c. First, you have to simplify this expression here, and it's 5 over 2. So you will get 3 u to the power of 5 over 2 over 5 plus c. But now you have to go back in your working here. You have to see this substitution. So you could just substitute u here. So you get 3 times 2x plus 1 to the power of 5 over 2 over 5 plus c. There you go. All right. Yeah, that is how you do it. Let me go back. Um, yeah. I think I am correct. Yeah, 5 over 3. I think I'm correct. Yeah, 3. Yeah. I got it correct. Sorry, I have to recheck my working. But yeah, I think that is the answer. But if you guys like have a different answer than me, please do let me know. That I could check my working, and then I could like um avoid errors in my calculations. All right, so let's move on to another part, just question B here. Now they give us an integral, which is 2x plus 3 times with the square root of x plus 1 dx. Okay. Now you might be thinking, okay, I could just expand this, but it's going to be very difficult for me. So whenever I have to deal with this kind of questions where it has square roots, cube roots, I will always make sure that this part here is in a single term lah, like square root of a, square root of u, because I want to deal the square root easier lah. All right, and then all right, before I move, yeah, okay, let me show you that. So right now, I want to make sure my square root is in a single term, not this one, it's x plus 1. So I use the substitution method, which is I let u is equal to x plus 1. Okay, x plus 1. So now we differentiate as usual. Du is equal to dx. Very simple. But then how do we deal with this? Because this term here is in terms of x lah, but we already changed it to in terms of u. So how do we change x into u? By just expressing this into terms of x. So you will get x is sorry in terms of u. So you get x is equal to u minus 1. So all of the terms in x, all you have to do is just substitute to get u for x. In simpler words, I just substitute x with u minus 1 plus 3 square root of u du. Now, from here, just simplify it, okay? Just simplify it. Sorry, it's not square root, this is the integral of 2u plus 1 square root of u. Then from here, yeah, all you have to do just expand it, very easy. So you will get integral for 2u to the power of 3 over 2 plus u to the power of 1 over 2 du. And then from here, just integrate it as usual. So you will get, oh sorry, you should get 2u 3 over 2 plus 1 over 3 over 2 plus 1. Then u to the power of 1 over 2 plus 1 over 1 over 2 plus 1 plus c. And then from here, you could simplify it. So I think you should get 4 u to the power of 5 over 2 over 5, okay, plus 2 u to the power of 3 over 2 over 3 plus c. And then remember, you have to go back in your previous working here, and you have to resubstitute back u here. You should get 4 times with x plus 1 to the power of 5 over 2 over 5 plus 2 times with x plus 1 to the power of 3 over 2 over 3. That is how it is done. Okay, really nice. So it's a bit tedious, and it takes time to determine which one you want to substitute. But the more you do it, like I said, the more you do it, the more you recognize which one you want to substitute. All right. So, is there any questions so far before we move on to much more not that difficult lah, but not that advanced as well, but another question, okay? Yeah,
No question.
no question, eh? All right. No. All right, so let's move on to the next question. All right, so here we are. We have to deal. Okay, we have this one. Question C. We have to integrate 2x over x squared minus 1 dx. Now, when you see here, to substitute, this is the x squared, right? Or x to the power of 2. Then you see our numerator is 2 times x. So from here, you could see, oh, we could substitute x squared minus 1. Okay, because when you substitute it, u is equal to x squared minus 1, you get du is equal to 2x dx. This is similar to this, right? So you obtain integral 1 over u du. And then when you see a rational function here, oh, no, sorry, reciprocal, then you know that you use ln to integrate, you will get ln modulus of u as a function of u plus c, and just resubstitute back, you get ln x squared minus 1 plus c. Right, that's how it's done. Okay, so that's good enough integral. Man, there is a lot of integrals here. Okay, so okay, one last integral. Then I'll try to, yeah, we will go through for tricks. Yes, for trigonometry. Okay, now for d here, we integrate 3x squared plus 1 times e to the power of x cubed plus x minus 2 dx. Now, you see our exponent here and our term here. Now, the relation between these two is where is a 3x squared plus 1 is the derivative of, okay, the derivative of x cubed plus x minus 2. Okay, so let us substitute this power. Let u is equal to x squared plus x minus 2. And then as usual, you differentiate in respect of x, du is equal to 3x squared plus 1 dx. And when you rearrange this, okay, let me show you when I rearrange this. So e to the power of x cubed plus x minus 2 times with 3x squared plus 1 dx. So it is similar, right? Similar. So you could just substitute as including the power here, you will get e to the power of u du. And you know, for this exponent, for the integral, you will get the same thing. So e to the power of u plus c, and you know u is equal to x cubed plus x, e to the power of x cubed plus x minus 2 plus c. Okay, that is how it's done. Nothing much. Okay, so let's move on to a much more difficult questions which involve trigonometry. So I want to try this question. Okay, and then we move on to the second technique, which is the integration by parts. Now, integrate cosine to the power 3 plus a plus sorry times the sine of x. Now, how do we apply the substitution method? Now, usually whenever I see these kind of questions, right, I substitute the trig that has the power lah. So let u is equal to cosine of x, and then I differentiate in respect of x, so you get du is equal to negative sine of x dx. And then, yeah, you have to express it only in sine of x dx is equal to negative du. As you can see here, this is very similar. So now you are left with integrate u to the power 3 times with negative 1 du, and then integrate as usual negative u to the power 4 over 4 plus c. And then just recall back in your working here, you know that u is equal to cosine of x, and all you will get is cosine of x to the power of 4 over 4 plus c. And there you go. That's how it's done. Nothing much. Okay. All right. So that's about it for substitution method. Okay. So no questions there. I could move on to integration by part. Right. And I'm nice. Okay. Yeah. No question. All right. Nice. Okay. So integration by part is that you have this. You have to express it in this. You integrate u dv is equal to uv minus integrate v du. Okay. Now you have to choose which one is simpler. Okay. You have to choose which one is simpler to integrate. This one is the question. This one is the one that you want to deal with. This one is what you don't need to integrate a lot, but this one you have to make sure that it's easier to integrate. So let me show you by example. Okay. Hopefully I remember how to do this. So it's been a while, okay? It's been a while. But yeah. So let us try with integrate x times with square root of x plus 1 dx. Now you have to use integration by part to solve. You could use substitution, but it depends on the question. But after I showed you the integration by part, I'll show you as well for use substitution method for this particular question, okay? So now you have to choose which one is your u and which one is your dv. Okay, so all right, I have to deal with this. Um, okay, let me take u is equal to square root of x plus 1. Yeah, that looks nice. And then, yeah, yeah, wait, hold up. dv, d, dv. Hmm, give me a second. Integrate. All right, let me pick x first. I want to see, is it simpler? So u is equal to x, and I see that, okay, du is equal to dx, no problem. And then my dv is square root of x plus 1 dx. So v should be, yeah, yeah. My v should be, yeah, let me remember, let me add that. Okay, 2 x plus 1 to the power 3 over 2 over 3. Okay. And yeah, I don't think that you have to put plus C because this method, I'm not sure. Itulah, saya takut juga nak kata tak perlu C. So, but usually when we deal with indefinite integrals, there should be C lah. But I think for this technique, you don't have to. But I'll confirm it later on. Hopefully, I remember lah that I have to confirm this. But yeah, so now we know. Okay, let's write back down formula. So you get uv minus integral dv du. Now, you see here, if we compare, yes, lah, it's like this. So square root of x plus 1 dx. So it's equal to x times with 2x plus 1 to the power 3 over 2 over 3, and then minus with the integral for 2 over 3. X plus 1 3 over 2 dx. Yeah, because our du is dx lah, and then our v is this. Okay. So from here, this we don't need to integrate lah, but only this. Okay, but this is easy because we already learned the basic rules of the integration. Or if you want to do use substitution, then be my guest. You could use substitution, no problem. So okay, first I want to make this one this so it looks nicer. Okay, nice. And then here, just integrate as usual. You get 2 over, wait, let me do it one by one. 2 over 3. Um, x plus 1 to the power 5 over 2 over 5 over 2 plus c, okay? And then you could move on to 2x plus 1 to the power 3 over 2 over 3 minus 2 over 3. Sorry, if I want to simplify, yeah, I could simplify it to 10 over 15, or to make it simple, right, I just factorize 2 over 3 out here. You get x plus, sorry, x times x plus 1 to the power 3 over 2 minus 2 over 5. 2 times x plus 1, 5 over 2 over 5 plus c. Yeah, that you should get. Yeah, all right. Wow, it's been a while. I haven't done this kind of technique. You know, right? I'll be learning this technique in calculus too. That's the funny part. But yeah, yeah, that's about it. Nothing much to do. Yeah, but the important thing is when you try to use this technique, you have to find, you have to make sure this. You have to find where it's simple to integrate lah. Simpler than this. Okay. If it's not simple yet, you have to use integration by part yet again. Okay. Now that is the hardest part lah, because you have to do it all over again. And until you find integral VDU in a simpler form. Right? Okay. So yeah, as I recall, let us try and use the technique which I mentioned earlier, the use substitution. So let's go here. X times with x plus 1 dx. Now, I know, as usual, square root, I use the use substitution. So that u is equal to x plus 1, du is equal to dx. This implies that we can express in terms of u, which is x is equal to u minus 1, and then go back to your integral and just substitute everything as usual, du. And then from here, you will get integral of square root, sorry, not this is square root anymore, is u to the power of 3 over 2 minus square root of u du, and from here, just integrate as usual. So you will get 2 u to the power 5 over 2 over 5 minus 2 u to the power of 3 over 2 over 3 plus c. Yeah, I did a mistake somewhere. Yeah, I did okay. Or did I did a mistake? Hold up, man. Give me a second. dv is equal to square root of x plus 1. I integrate it. 1 over 2 plus 1. Okay, and then I integrate it again. When I use x, my v is that. So yeah, that makes sense. Okay, I think it's correct. Okay, okay, 2 x plus 1 5 over 2 over 5 minus 2 x plus 1 to the power 3 over 2 over 3. Hmm. Hmm. Yeah, I don't want to keluar tadi. Oh, sorry. Ya, ya. Oh, saya want to keluar tadi. Okay, tak apa. Ah, okay. Yeah. I think that should not be a problem. But yeah, but why I tried substitution? Yeah, I did a mistake. Give me a moment, I want to check because for some reason I didn't get what I wanted. Hmm. Okay. Um. ah, okay. Why did I need X plus one? 1/2 x plus 1. Hmm. Because sebab itulah X. Kenapa lain eh? Sekejap, give me. Ya Allah, kenapa lain? Um, what happens if I do this? Hold on. Okay, so I want to try something else. 2 over 3 x plus 1. Okay, I factorize this. I will get x. Yeah, 2x plus, sorry, 2x plus 1 over 5 plus c. And then I will get 2 over 3. 5x minus 3 is 3x plus 1 over 5. Okay, betul lah. So, okay, betul lah saya buat ni. Itulah guys. Sorry. Saya betul lah ni. Kenapa lain macam? Lain macam eh? Tak puas hati lah. Sebab saya cuba guna substitution method. And then I expand it, yes. That doesn't give me the same output as when I use the IBP. UX dx ni pula. Saya integrate ini. Sebab V 2 over 3. Okay, tak apalah. Mungkin saya kena simak balik lah my method here. Ya, saya kena simak balik. But it's okay. Alright, give me a... Sorry sangat. Sebab ni pun saya first time nampak soalan begini. So, then we go find my calculator integration. Well, guys, if you want to like check your working right, I suggest you find a... Well, later I'll give you the web, a link to a Aku website. Uh, all right, what's the answer? Yes, the answer should be this. This is the right one, where I use the substitution method. But then when I check here, I think I did something wrong, but I don't know where. Okay, let me redo it again. Hold on, give me a moment. Let's retry. Okay, because you should get the same value when you use the substitution method. All right, so let's go back here. So as usual, like I said, you have to choose U and DV, which one is simpler for when you change it to this form. Compare, but for me, right? Yeah. Okay, let's try that. Okay, U is equal to x. We differentiate du is equal to dx. dv is equal to square root of x plus 1 dx. V is equal to, I know x plus 1 is 1 over 2, and then this will give me x plus 1, 3 over 2, 2 over 3. Alright, so far betul kan saya buat ni? Betul kan? Tak ada masalah betul? Kan? Alright. And then we just refer back to this formula out here, where it will be, we integrate x square root of x plus 1 dx is equal to, okay, and then from here we will get 2x, x plus 1, 3 over 2 over 3 minus, and let me give myself some space. V is, okay, we integrate 2 x plus 1, 3 over 2 over 3 dx. Yeah, like this. But when I check it out, di lain. Why? Hmm. X dx 1 over 2. Pelik lah. And then I tried here. I integrate it as usual. Kejap ya. Allah. Korang semua boleh cuba ni sesama. Kita cuba sama. But give me a moment. Integration by part. Mana? X x plus 1. Alright. Fine. So, kalau saya tengok online punya website kan, dia kata jawapan saya untuk integrate by part sama. But then when you use substitution, sorry, use substitution method lain. Kan jawapan tadi saya buat adalah 2/3 x square root of x plus 1 to the power of 3 minus 4/15. Ni memang sama macam saya buat tadi, x plus 1 plus c. Okay. Sekejap. Ke saya terlupa tentang sesuatu? Sudah. Sekejap. Okay. Let me compare with... Okay, usually whenever I do this, I usually compare x is equal to, let's say, 1. One's simple. So 2/3. 1 square root of 2 to the power of 3 minus 4/15 square root of 2 to the power of 5. Okay, so here's our first answer. And then 2, 1 plus 1 to the power of 5/2 divided by 5 minus 2, 1 plus 1 to the power of 3/2 divided by 3. Kan ni differ by a constant. Allah, saya tak ingat dah. Kan beza ni. No matter lah. Nanti saya confirmkan dengan my friends. Saya akan confirmkan diorang sekali. But yeah, integration by part ni is tedious in a way. You have to know which one you want to use for this particular technique. Okay. But inshallah, we will continue tomorrow lah. Per week, we will have 2 sessions, inshallah. Okay. So yeah, we will continue tomorrow. So is there any questions before I end? If not, then I could end it now.
So far tidak. Just
Tiada.
this one lah, how kita confirmkan esok.
Yeah. I'll confirm it tomorrow. Okay. So Arina, Huzaifah ada? Alright. Okay, so if that's the case, then I'll end the recording first. Alright, thank you. Alright, so hello everyone, and today we are about to continue on with the techniques of integration. So give me a brief moment. So I'll have to find the notes for her. Where mana nota saya ni? Masya Allah. Sekejap saya tutup ni dulu. Okay, and then I'll present the yesterday's question because I know that I did correctly, so I'll be showing you that it's correct lah, but you have to simplify the expression. Okay, so give me... no. Okay. Right. So let us continue on with the question. Because yesterday I was showing you guys about the second technique, which is the integration by part. And then I also want to show you about using the first method, which is the substitution method. So yeah, only partial fraction. Okay, here it is. All right. So yesterday we talked about this one. The integral for x times with x plus 1 dx. Now, this first working I want to show you is by using the technique, which is the integration by part. Generally, we are just trying to express an integral in this form. Oh, sorry, you always like that. uv minus, sorry guys, uv v du. Okay. Now, the way you want to solve this is you have to make sure that this part here is simpler than this one. Okay. So how do we choose u and dv? Now, for me, right, I choose u because u is equal to x because it looks very simple. Okay. When I differentiate it, I will get dx lah. And then for dv, it will be square root of x plus 1 dx. Then when I integrate this, I will get um, 2x plus 1 to the power 3 over 2 over 3. All right, so now we have our variables. All we have to do is just substitute into the given formula. So now integral for x times with the square root of x plus 1 dx is equal to x, sorry, 2x times with x plus 1 to the power of 3 over 2 over 3. Then minus with we integrate for square root of, sorry, it's not square root, integrate 2 times x plus 1 to the power of 3 over 2 over 3 dx. Now, this is very simple. You could integrate this by using the basic rules of integration. Okay, so just integrate as usual and you should get this one. Okay, let me just write this. Minus, it will be, let me imagine, 5 over 3, and then flip it, you will get, yeah, 2 over 3 x plus 1 to the power of 5 over 2 divided by 5 over 2 plus c. Okay, remember for the indefinite integral, you have to add the constant. Okay, we already discussed this before. So now all you have to do is just simplify all of the terms. First, let me simplify the second term here. It will get 4 x plus 1 to the power of 5 over 2 over 15 plus c. Now I want to factorize, okay, the common terms. So from here we could see that x plus 1 to the power of 3 over 2 is the common term for both terms. So when you factorize this, yeah, when you factorize it, okay, 2 over 3, also 2 over 3 are also the common terms. So now you will have x and then minus with 2 times x plus 1 over 5, if I am not mistaken. Okay. From here, you can simplify it to become a single term. You will get 5x minus 2x will be 3x minus 2 over 5 plus c. Yeah, sorry, I forgot. Forgot to write down it. Yeah, okay. 2 over 3. And then here will be x plus 1 to the power of 3 over 2. And then from here, just simplify it as usual. So you will get um, 3x minus 2 over 5 plus c. Okay. Now the reason why I simplify it is because I want to compare by using the first technique of integration, which is use substitution. Okay, so this first part here is by using integration by part. How about if we use substitution? Now let us evaluate the integral yet again, but by using the first technique of integration, which is use substitution. So remember, if you want to substitute a term, pick one which is, it looks complicated. Okay, for example here I pick let u is equal to x plus 1. This because it's a square root and I would like to simplify the square root in an easier way, which is in a single term. Unlike in this square root, it's a binomial. Okay, a binomial means that it has two terms. So now we differentiate u in respect of x. You will get du is equal to dx. But how about this x? What do you do with this x? So remember, we express x in terms of u, it will get x is equal to u minus 1. Now, you will get an integral, which is u minus 1, the square root of u du, okay? And then from here, just apply, well, the rules that you knew. No, first you expand this. You expand it to become u to the power of 3 over 2 minus u to the power of 1 over 2 du. Then integrate as usual. You will get, the first one will be 2 u to the power of 5 over 2 over, sorry, over 5 minus plus 1 will be 2, u to the power of 3 over 2 over 3 plus c. Now, from here on out, just simplify it. No, before you simplify it, first substitute the term u in terms of x. So you get 2 x plus 1 to the power of 5 over 2 over 5 minus 2 x plus 1 to the power of 3 over 2 over 3 plus c. Now from here, factorize the common term, which is x plus 1 to the power of 3 over 2. You will get, um, yeah, x plus 1 power of 3 over 2. Then 2x plus 1 divided by 5 minus 2 over 3 plus c. Let me write here a bit. Okay, now just simplify the terms in the bracket, sorry, column, x plus 1 to the power of 3 over 2. All right, now here you will get 6x plus 6 minus 2 over 15. Oh, sorry, not 2, 10. And then here you can, well, basically you can simplify it. You will get 2 over 5, if I'm not mistaken, 2 over 5. That's 2 over 3. But if you want to, yeah, you could bring out 15 as well. So if we refer this, we could make it as 2 over 15. Now here, okay, so you will get x plus 1 to the power of 3 over 2. And you are left with 3x minus 2 plus c. I'm sorry, I forgot my plus c here. And there you go. So both techniques will give you the same value for the integral. Okay, but you have to simplify first, then you could see lah, that both techniques work, right? So any questions so far? If there is no questions, I could move on to the next question. Okay, all right. Okay, so let's move on to, okay, sorry, yeah, if my neighbors are playing their fireworks because it's Chinese New Year, right? So very sorry for the disturbance, but let them enjoy. Okay, so let's evaluate this integral. So we have been given an integral which is ln x dx. Now, obviously, we can't use substitution because there is nothing to substitute, and we don't have the formula to evaluate this integral. So how do we do it? By using the second technique of integration, which is integration by part. So first, we choose which one is our u and which one is our dv. So from here, to make things simple, I would like to, yeah, I want to make u is equal to ln x. So this should get du is equal to 1 over x dx, and my dv is my dx, and here my v should be x. Now, oops, someone just popped in. I think it's Huzaifa, right? Hello, Huzaifa. Sorry, yeah, I started early. Not that early, lah, but I started without you. I'm very sorry. Yeah, but just now I just it's okay, it's okay. But okay, let me recap a bit. All right, let me recap. So from here, remember yesterday we have a bit trouble with the question involves x times square root of x plus 1, and I showcased both of the techniques applied to the question. But then yesterday we got a different output, right? But I forgot that we could simplify it. So from here, firstly, I tried using the integration by part, and then I simplified the answer in this form. And then I tried using the use substitution, and then I simplify it also, getting the same form. So both techniques work lah for that particular question. So that's about it. I basically recap yesterday's lesson. Okay. right? Now you didn't miss much, but if you want my working, then I would lovely to send to you in the group, like in the group, right? Okay, so for this is our second question, and now we are dealing with an integral which is ln x dx. And now we can't use substitution because there's nothing to substitute. All we can do is by applying the integration by part technique. So I choose u as ln x because it's easy. You will see it soon when I apply it to the formula given. So now it should be ln x, and I should put x in front. X ln x minus integral, which is v v du is x times 1 over x dx. And here we could simplify it to become 1, so it should be 1 dx. And then from here we could integrate as usual plus c, and there you go. You got your final answer. Nothing much to reconsider. Nothing much to consider lah. That's about it, generally. I think that's about it. Yeah. All right. So, any questions? I hope, hopefully, this it's just a really direct question. Nothing much to be worried about, right? Like I said, I'm sorry if the it's really noisy because it's Chinese New Year and my neighbors, most of them are Chinese, so they celebrating. Okay. All right. Let me go back. All right. Okay. So previously, right. This here. Okay. This working is when I use integration by part. And yesterday we got onto here, right? So the way I simplify it is by finding the common terms for both terms. So I found 2 over 3 and x plus 1 to the power of 3 over 2. And now I am left with this unsimplified term. So what I do is I simplify it. I simplify it. And well, that's about it. I just simplify the expression. So how about the use substitution method? Will I get the same output? The answer is yes. I just, oops, what happened here? Oh, sorry. Okay, I just simplify it, right? Hopefully you guys can see it lah. But yeah, as usual, I found the common term, which is x plus 1 to the power of 3 over 2. And then I simplify the term in the column there. And there you go, I factorize 2 over 15. So as you can see here, it's very similar to when I applied the technique by integration. So it means that this kind of integral, we could apply both techniques, use substitution or integration by part, no problem. Okay, so that's about, yeah. I didn't simplify it yesterday, but both of them are very similar. Okay, it's just that whether you simplify or not. Okay, hopefully that clears up yesterday's confusion about both techniques applied to the integral. Or any more questions, Zaifa? Does our answer still acceptable? Um, I mean, honestly, right, to be safe, if you can simplify it, that I suggest you can simplify it. Like, in other words, if you can factorize the expression, then just factorize because, I mean, the more the better, right? The simpler the better, in my opinion. But I think there should be no problem. I think based on the scheme, because the scheme answers for each year is very different. They always change it up, but the idea is still there. And for me, to be safe, you simplify it if you can like identify the common terms, identify if you can factorize it or not, then go ahead, just simplify it. Just give your answers in different forms so that you could be more safer, in my opinion. Right? But if you um like how I did for my PSPM, I simplified it lah. Any question that I could find, I simplify it to the simplest term if I can. Right? So that's how I do it. All right. Okay. All right, so yeah, this second question here is I applied the integration by part for this kind of integrals, which I cannot apply use substitution, right? I can't apply. So there's only one technique which I could use, which is integration by parts. So remember, you have to determine which one will be your u and which one will be your dv, because later on, when you try to integrate u, sorry, when you try to integrate v in respect of du, then in other words, it's going to be tough lah if you can't determine which one is much more simpler. Okay, so in other words, try and error. Right? There's nothing. It doesn't hurt to try. Okay, if you're stuck, right, it doesn't hurt to try which one works the best. But the more you do it, the more you recognize the pattern for each question, and you, inshallah, you will not have any worries to solve it. Okay. All right. So hopefully there are no problems for question D. Now let us continue on for question C. All right. Question C is a bit interesting. Everything's interesting, honestly. So, okay. So let's try, yeah, let's try question C. My lecture ada ajar teknik bypass kena guna formula LPT, tapi salah saja bagaimana tak guna LPT. Oh, LPT means logarithm, polynomial, exponential, trig, right? And if I'm not mistaken, LPT, yeah, LPET, I think, right, for from the left, right, we prioritize this log, I think, yeah, logarithm, and then polynomial, and then exponent, and then trig, like this, right? Then we like prioritize this. So we prioritize logarithm. I think, yeah, we prioritize logarithm as our u, right? If I'm not mistaken. Yeah, yeah, good, good, good. I really, I did, yeah, I forgot about LPET. I see. I see. Okay, if that's the case, right, can you share the particular question and we could like discuss it together? Because when you told me that the scheme uses polynomial, not log, then I would like to try if I use log, logarithm first, right? I think, right, it depends on what you want to find. I think polynomial, yeah, it depends. But I want to try. So yeah, give me the question and I'll check it out. Yeah. You can send in a group if you want to. No problem. Okay, while we wait, I want to get some water. Like, yeah, I'll give you guys 2 minutes lah to get something first, right? So give me a brief moment. All right, while we wait, okay, so I have a few advices. I asked my academic advisor, UM, I asked him a few advices on how do I improve, how do I strengthen the skills on problem solving, because in today's world, everyone industries wants an employee which can solve problems lah, to be a problem solver. So mathematics is a way to enhance that particular skill, problem solving. But how do we achieve that kind of skill. So he advises me, but this is for mathematics. Obviously, mathematics, you cannot just read the notes. You have to write down the paper, solving questions, apply what you know. Okay. And then, yeah, just do tutorials. But I suggest that you guys just don't refer the answer first. Do the tutorials first. Okay, I know it's tough sometimes. And even for me, for like proving questions, for for limits especially, in my degree, I have to it involves a lot of proving and a lot of theory. So it gets difficult as time goes on. Lah. But like it or not, you have to write down what you are working on. You cannot just read proofs and say, oh, I understand this. You have to write it down so that okay, while you're writing it down, you can see the flow of your working, which is very useful. Okay, so because I've already sent it, okay, he let you, I see. All right. Okay, let's try. Okay, so the question is, they give us an integral. Okay, I'm not gonna solve the definite integral. I'm gonna solve it indefinitely. So let us try x squared ln x. All right. So the scheme tells us that they substitute u is equal to x squared. All right. So let's see. Mm, okay. Now I know why. This is because, right? Hence, like by using integration by parts, show that ln of x dx is equal to x ln x minus x plus c, and hence. Now, why hence? Usually for questions, especially PSPM and then in university, whenever there's a term hence, you have to refer back to the questioner. Means that the information that you gathered from the previous question, you have to use it for that question, hence. Okay, so that is why it uses u is equal to x squared. They want to apply v is equal to x ln x minus x, which refers back to the original question. That is what hence. Unless if they didn't mention hence, then you can use logpad, no problem. But they mention hence, so you have to refer back to the original question and use that information in your working. That is why lah. I cannot, yeah. But generally, right, if they didn't mention anything about hands or the previous question, then of course, you could just apply it. Yeah, because the keyword hands. So you have to use the information from the previous question. All right. Uh, but anyhow, I want to try, let's try by letting u is equal to ln x, shall we? Okay. So simple as this. You want to make this in a simple format. So u is equal to ln x, d is equal to 1 over x dx. Now dv is equal to x squared dx, and our v is x cubed over 3. Now, based on the technique, uv will be x cubed over 3 ln x minus we integrate 1 over x times with x cubed over 3 dx. Yeah, move this around. So from here, okay, now, well, from here, just solve it lah. So ln x over 3 minus, yeah, this could simplify it to become x squared over 3. Now, when we integrate this, it will get x cubed over 9 plus c. Now, obviously, we can factorize this in this form. Boom, boom, boom. Top, 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 top. That is the answer. So if I go back to the question, um, Yeah, I think you should get what I get lah. So let me let me try out 1 4, right? So will I get the same answer as the scheme? All right. And then the second one. All right. And then yeah, I got the same thing. The same thing. Right. So basically, right. Yeah, this question was quite hard. It took a very long time. Yeah. So basically, the scheme, right? It just basically you have to use the information from the previous question to use the well. It's just tedious, you know. But yeah, that's how it is done. But yeah, this is the alternative method if they don't mention hands, so you don't need to refer to the original question. But yeah, that's about it essentially, right? Right. So yeah, let's move on. All right. So we are being given another integral involving exponents here. So x times 2 to the power x dx. Now, since Joseph mentioned about LPT, or as I call it, LPET, so logarithm, polynomial, exponential, trigonometry, meaning that from left to right, we prioritize the left first, that goes to the right lah. Okay, that's how it is. Okay, now since we have a polynomial, x is a polynomial, and then we have an exponential, which is 2 to the power x, we prioritize x. So u is equal to x, du is equal to dx, dv is equal to the power x, and then v is equal to 2 to the power of x ln 2, right? So now as usual, apply by using integration by part, you will get x times 2 to the power of x over ln 2 minus, we integrate 2 to the power of x over ln 2 dx. As usual, solve it, no problem. So you will get 2 to the power of x over ln 2 to the power of 2 plus c. And then from here, you could factorize it, no problem. X minus 1 over ln 2 plus c. Ta-da! That is how it is done, right? Okay, really nice. Wait, did someone left? I think someone left. Oh, someone left. But yeah, I think they have problems with their Wi-Fi, so it's understandable lah. Right, so any questions so far? Hopefully none. Right. Yes, it's really just direct. Nothing much to worry about. All right, let's move on. So yeah, I'm a bit I have sniffles here. Hold on. There's someone PM here. No. All right. Send that shit down. Oh, okay. All right. Um. Okay, let's try one more, and then we will go to our final for this subtopic before we got into the definite integrals. But I think next week we will go through definite integrals. Okay, but for now, let's finish this subtopic here. Let's go with, all right, let's try with integral x times cosine of 2x dx. Okay, now by applying LaPet, all right, LaPet. Okay, we prioritize polynomial, then the trigonometry. So let u is equal to x, du is equal to dx, and here will be dv is equal to cosine of 2x, sorry, cosine of 2x dx, and here will be v is equal to sine 2x over 2. Okay, now as usual, apply the technique, and you should get x times sine 2x over 2 minus, we integrate sine 2x over 2 dx, and then from here, we could solve it, no problem. Yeah, I think Wait, if I integrate this, yeah, I should get this lah. Let's see. Ta-da! Really simple. Nothing much to worry about. Okay. Alright, as far as I know, if I integrate sine of x, I should get negative cosine of x. So yeah, sine x. Yeah, I think I'm correct lah. Oh yeah, correct. Alright, nice. Alright, so that's about it. So that's about it for the techniques, which is use substitution, integrate by part, and then the last one will be integration of a rational function. So this part here is just basically you recall back to your first semester for mathematics. It's about partial fractions, okay? So let's try to solve one particular question. All right, so pretty simple. Integrate 5x minus 3 over x squared minus 2x minus 3 dx, sorry. Okay, now first things first, I want to know, can we factorize the denominator? If you can, then go ahead, just factorize it. So 5x minus 3 over negative 3. I think this will be x squared, sorry, x minus 2, wait, x minus 2, wait, sorry, it's not x minus 2, x minus 3, and then x minus 1. No, x plus 1. Right, wait, let me check. X squared minus 3x minus x minus 3. We factorize x minus 3, x. Oh yeah, this is plus. Oh, okay. Oh yeah. Okay. As you can see here, we can't simplify this particular expression. So you have to bring this term out like this. You have to recall back to your partial fractions, right? So x minus 3 times with x plus 1. So this will be a over x minus 3 plus b over x plus 1. Now, there are many ways. You want to compare the elect terms. You want to use the let x is equal to this value. But for me, right, we compare the elect terms, right? So let's compare. So we will get 5x minus 3 is equal to a times x plus 1 plus b times x minus 3. Now, obviously, you just group it the same terms. So 5x minus 3 is equal to a plus b x plus a minus 3b, right? So from here, you could see, you can compare the like terms. So a plus b is equal to 5, and a minus 3b is equal to negative 3, no problem. So how do we solve from here? Now, simultaneously, right? Simultaneous equation could use. So a is equal to 5 minus b, and just use back to back substitution. So this will get 5 minus b minus 3b is equal to, negative 3. There will be negative 4b is equal to negative 8. B will be 2, and you get your a here, which is a is equal to 3. In other words, 5x minus 3 over x minus 3, x plus 1 is equal to 3 over x minus 3 plus 2 over x plus 1. Now apply this back to the integral. So you should get 3 over x minus 3 dx, plus 2 over x plus 1 dx. Now, as you recall about the formulas for the integral for rational functions, should get 3 ln x minus 3 plus 2 ln x plus 1 plus c. There you go. Right? But if you're uncertain, you could use substitution. But well, nothing much to worry about. But yeah, if you want to use substitution, then go ahead, no problem. Sorry. Mm, right. All right. So yeah, as usual, any questions for partial fractions? If not, right. Um, I don't want to show more because it's just the same thing for the rest. I want to solve the questions which I shared last time on the WhatsApp group. So let me open the file real quick. And I think this is the one. Wait, let me go to open. Ah, yeah, here you go. All right, so no questions there? Because I want to solve a few questions, the file that I shared with you guys, right? Right, okay. So yeah, let me share. Ta-da. All right, hopefully you guys can see my screen now. Okay, there. All right. So I used LaTeX lately. And when I use LaTeX, I create questions up. And it's the 10th January, so it's a long time. Well, technically, it's not a long time. It's just like around 11 days ago. And I haven't got the chance to solve it. So maybe we have the time here, we could solve a few. And I think there's one question, particularly at this one. Yeah, question F, don't need to do it since, well, it involves substitution, but not the one that we learned, right? But the rest is easy for me. Well, con well, it's not that easy, but if you know how to solve, right, inshallah, no problem, right? So appreciation here. So thank you to HI, Arina, Zaifa, Shafia for trusting me on teaching you guys. It's a small appreciation for those who are with me. Yeah. Right? Okay, so let's try solve the first question. So let's go here. All right. Yeah, Arina, ada masalah di wifi ya. Sorry. Hari tu dah tadi dah habis lah. Sekarang ni, okay, for now, right now we'll be going through the file that I shared 11 days ago or around 2 weeks. Okay, so it's a really cool file. So all of this just consists of substitution. Yeah, just substitution. So let's go through. It's okay. I understand because I am also a chemistry student, so the area that's really terrible if you want to have online sessions like I'm doing right now. So it's really understandable. So no worries. All right. So now we have this particular question. How do we solve it? By using use substitution, because all of the questions that I wrote here is just use substitution. So let's try solve one. Hopefully, we could do it. Now, for question A, wait, let me share my tablet screen. So I'll be sharing it simultaneously. So yeah, hopefully you will not cause any problems. Wait, yeah, let me stop sharing for the other one. Right. Hey, okay, so let's go through for the first question. Now, the first question here, it states that we have an integral, which is when x times with x minus 1 to the power of 10 dx. Now, as usual, whenever we have a higher power, we substitute that lah to become a single term. So we let u is equal to x minus 1, and we differentiate in respect of x, you'll get dx here, and then at the end of the day, you will get, or here implies that you express x in terms of you will get x is equal to u plus 1 times u to the power of 10 du. And here, you will get u to the power of 11 plus u to the power of 10 du. And integrate it as usual, u to the power of 12 over 12 plus u to the power of 11 over 11. This is equal to x minus 1 to the power of 10, sorry, not to the power of 10, to the power of 12 over 12 plus x minus 1 to the power of 11 over 12 over 11. Right? So that's about it. So let's go through a hard question. So this question is very interesting because not a lot of people can solve it on their first try, including me. Well, I took around like 10 minutes to think about it, but it's very cool. So let's go through question B now. We integrate a square root of x minus 1 over x to the power 5 dx. Now, how do we solve this? Now, most people will just directly go into it, okay? But finding which term should I use substitution. But you have to be careful. Yeah, try asking yourself, can I simplify this? Yes, you can. There are many ways to simplify, no problem. But the way I simplify it is that I factorize the denominator. Now, check it out. So we start with x minus 1, then we have x to the power 4 times with x dx. And x to the power 4, I could separate this fraction to become, well, 1 over, or square root of 1 over x to the power 4, square root of x minus 1 over x. Yeah, so you could use this. This is one of the properties of square root. So no problem, just do it. And you could solve this. You will get 1 over x squared, square root of x minus 1 over x dx. And here, you could create two terms by separating this fraction up to become 1 over x squared, square root of 1 minus 1 over x dx. Now, you could use substitution method. So let u is equal to 1 minus 1 over x. You differentiate this in respect of x, you should get 1 over x squared dx, right? And then, as you can see here, we will get is equal to, we integrate the square root of u du, and then just simplify it as usual, nothing much from here, plus c, and then 2 over 3 times with 1 minus 1 over x to the power of 3 over 2 plus c, and tada, no problem. Okay, nothing much to worry about. So yeah, this question is a bit tough lah, because you have to see that, oh, I can simplify it in another term, and I could apply u substitution, no problem. All right. All right, we have around 10 minutes left. So, which question should I try? Which one is the hardest? Okay, this question is not, well, it's fun. Okay, question G. Now, I would like to give you guys 2 minutes to solve this. All right, if you guys can solve it, then bravo, you're really good for use substitution. All right, so I give you 2 minutes until 9:53, and then I'll show you the working. All right, so go ahead, try it out, and I'll see you at 9:53. All right. All right. I don't think that 2 minutes is enough, but no worries. Oh, okay. Okay, cosine of ln of x. All right. Okay, it was like interesting, interesting. Okay, how about the rest? Well, if you guys can't, it's okay if you guys can do it. Same. All right, nice. Okay, how about you, Arina? It's okay. It's okay. If you guys can't get it, it's fine because we are learning. As long as we are on to learning, then it should be no problem. Inshallah. All right. Okay. All right. So let me show you. So how do we solve it? So you see it right, like automatically. You say, oh, ln of x. So obviously, when you substitute u into it, you get u is equal to ln of x. Then you differentiate it, you get 1 over x dx. And well, well, as you can see, since this is the same as this one, so yeah, from here on out, just solve it as usual, and there should be no problem. So that's the answer. So congrats. But it's okay for those who didn't get it, all right? Because we are learning, and for those who got it, that's a bonus for you guys, right? As long as we are working hard to achieve the best, then inshallah, no problem. All right. So, okay, all right. I have to admit that's just pretty straightforward. Okay, last one. Hmm. Yes, everything's last one. Mm, well, this is really simple, honestly. But yeah, this is very similar. All right, it's for fun now. I think you guys can answer this. So we integrate 1 over x cubed times square root of x squared minus 1 over x squared. All right, try and solve this one now. And yeah, as usual, 9:57 will be, well, 2 minutes, 9:57. All right, go ahead. All right. Yeah, this is, well, it's not that. Okay, let me show you a speed runner. Right. Okay, so I could see here that I can simplify this. Inside my square root. So, oops, sorry. I will get 1 over x squared dx. Now let u is equal to 1 minus 1 over x squared du. Wait, yeah, I differentiate. So du will be 2 over x cubed dx. In other words, 1 over 2 du is equal to 1 over x cubed du, sorry, not du, dx. And from here, you could square it over 2 du, substitute as usual. And then integrate it, you will get 1 over 2 times 2 over 3 u to the power of 3 over 2 plus c. And then 1 over 2 times with, well, I get 1 over 3 lah. 1 over 3 times with 1 minus 1 over x squared to the power of 3 over 2 plus c. That is about it, right? Oh, that's fun. So do you guys got the same answer, which is yeah, one over 3. Oh yeah, like that. That is how it is done, right? Hopefully it's not that fast, but that is okay. Okay, so that was fun. Well, it was fun. I see you guys have like grown in a way that you guys could solve, inshallah, and you guys understood, right? And it's okay if you guys don't understand much. Just PM me or just ask me in the group, inshallah, if I have the time and energy to face that question, inshallah, I might answer. Okay. So, is there any questions before I end the meeting? Because I have another meeting after this. No? All right. Okay. So, if there are any questions and you are like a bit shy, you could ask me directly WhatsApp or any other platform that you prefer. Okay. So that's all from me. Thank you so much for joining today's session. Hopefully, we could meet